We've got a fascinating paper to unpack today, all about making LLMs more adaptable and efficient.
Oh, yeah. This one is super interesting.
It's titled Transformer2, Self-Adaptive LLMs, from the folks over at Sakana AI and the Institute of Science, Tokyo.
Lots of really cool ideas in this one.
It definitely seems like it. The core concept here is self-adaptive LLMs, right? Models that can basically shift gears in real time depending on the task at hand.
Yeah, and you know how we've always talked about how traditional fine-tuning is so resource-intensive?
Totally. It's like trying to fine-tune a model with a million knobs, you know?
Exactly. This paper proposes a whole new approach called singular value fine-tuning, SVF for short. Instead of tweaking all those parameters, it focuses on something called singular values within the model's weight matrices.
Singular values. I vaguely remember that from linear algebra class, but how do they apply here?
Well, imagine you have this big block of clay, right? Instead of reshaping the whole thing, you have these special tools that let you adjust the density in specific areas.
Okay, so it's a much more targeted approach.
Exactly. And those singular values are kind of like the essence of that clay. You know, they capture the most important information about the matrix.
So by tweaking those singular values, they can change the model's behavior with much fewer adjustments.
Precisely. But here's the really clever part. They've incorporated reinforcement learning, or RL, into the training process.
Oh, interesting. So the model isn't just relying on labeled data, but actually learning by doing.
Yeah. It's like giving the model a reward every time it successfully adjusts its singular values to perform a specific task better.
So it's all about optimizing for performance rather than just mimicking patterns in the data.
You got it. And because SVF is much more stable than other fine-tuning methods, it works really well with RL. It allows the model to learn faster, especially when there's not a lot of data to work with.
That makes sense. So we have this new SVF method for fine-tuning, but the paper goes even further, right? They actually built an entire framework around it called Transformer2.
Right. Transformer2 uses this really interesting two-pass system.
A two-pass system. Okay, tell me more about that.
So the first pass is like an analysis phase. The model observes what it's doing in real time and tries to figure out what kind of task it's dealing with.
So the model is kind of doing some introspection, like, what am I being asked to do here?
Hooray. Yeah, exactly. And then, based on that self-assessment, it moves on to the second pass, which is the adaptation phase. This is where the model uses SVF to actually change its weights and tailor itself to the task.
Okay, so it figures out what it needs to do and then adjusts its own brain to handle it. Pretty cool.
It is. But now the question is, how does the model know how to adapt?
Yeah, good point. How does it know what to change?
That's where expert vectors come in. Basically, each expert vector is a set of those singular values we were talking about, but they've been specifically trained to be really good at a particular type of task.
Okay, so it's like the model has a toolbox of specialized skills, and it needs to pick the right tool for the job.
Exactly. Transformer2 can actually switch between these different expert modes depending on what's needed. It's not just a one-size-fits-all model anymore.
That's really impressive. But hold on a second. How does the model actually decide which expert to use? Is it looking for keywords or something?
Well, they explore a few different strategies in the paper. The simplest one is called prompt engineering. Basically, they craft the prompt in a way that helps the model classify the task and pick the right expert.
So they're giving the model some hints to nudge it in the right direction.
Right. But then they also have this other strategy called the classification expert.
Ooh, a classification expert. Sounds intriguing. What is that?
So they actually trained another LLM, also using SVF, but this one is specifically trained to identify the task.
So it's like an LLM whose job is to tell another LLM what to do.
Haha. Yeah, you could say that. This classification expert can analyze the input much better than just looking for keywords, which lets it choose the right expert more accurately.
So two pretty cool strategies already, but I have a feeling there's more.
You're right. They also explored a third, even more sophisticated strategy called few-shot adaptation.
Few-shot adaptation. Okay, now I'm really intrigued. What's that all about?
Well, instead of just picking one expert, this strategy actually combines multiple expert vectors, like blending them together.
Interesting. But I imagine figuring out the right combination must be really tricky.
It is. And to do that, they use something called the cross-entropy method, or CEM. It's an optimization algorithm that helps the model experiment with different combinations of experts to find the best blend for the task.
So it's like The model is running its own internal A/B testing to figure out the best recipe.
That's a great way to put it. And what's fascinating is that this few-shot adaptation strategy seems to work the best overall. It seems like the more information the model has about the task, the better it can adapt. But of course, the big question is, does this actually work in practice?
Yeah, that's what I was just thinking. What kind of results did they see with Transformer 2?
Well, the results are pretty impressive, I gotta say. Across all sorts of tasks, from math problems to code generation, SVF consistently beat the more traditional LoRA method.
So it's not just more efficient, it's actually better.
Yeah, they got better accuracy with fewer parameters. But there's one finding I think you'll find particularly interesting. And that is, well, they found that Transformer 2 could even adapt LLMs for visual question answering.
Whoa, hold on a sec. Are you saying they took a model that's primarily trained on language and made it understand images too?
Yeah, exactly. They did it using those same expert vectors. It's pretty wild, huh?
It is. It seems like Transformer 2 is capable of some pretty amazing things. It's not just adaptable, it's also incredibly insightful. Like, it's able to understand the underlying structure of knowledge and use that to solve problems in ways we might not have even thought of.
That's a great point. It really highlights the potential of self-adaptive AI, especially for things like lifelong learning.
Yeah, imagine AI systems that can constantly learn and grow their knowledge, just like we do. It would be incredible.
Totally. But, like with any new tech, there are also some challenges we need to be aware of.
Right, of course. What kind of limitations are we talking about with Transformer 2?
Well, for one thing, a lot still depends on the base LLM itself. If the foundation isn't solid, even the best fine-tuning techniques won't be enough.
So garbage in, garbage out, even with a fancy new framework like this.
Pretty much. We still need to keep pushing for better base models.
Makes sense. What other challenges are there?
Well, scaling is a big one. Right now, they've only experimented with a handful of expert vectors. But what happens when we have hundreds or even thousands of them?
Yeah, managing all those experts could get pretty complicated.
Definitely. And that optimization process we talked about, the CEM, it can get really computationally expensive as the number of experts grows.
So some technical hurdles to overcome, but still, the research is incredibly promising. It feels like a huge step toward creating truly self-adaptive AI.
I agree. And beyond the technical stuff, there are also some bigger questions to think about, like, what are the ethical implications of all this?
That's a really important point.
Yeah.
We need to make sure these systems are aligned with our values and goals, not just that they're smart.
Exactly. It's a conversation we need to keep having as these systems become more powerful.
Absolutely. We can't just sit back and watch as this technology develops. We need to be actively involved in shaping its future.
Well said. This research opens up so many possibilities, but it also raises some big questions. It'll be really interesting to see where this all goes.
Okay, so before we went to that break, we were talking about how Transformer 2 is capable of some really incredible things. And there was one finding in particular that you thought I'd find pretty mind-blowing. Care to elaborate?
Oh, yeah, definitely. So you remember those expert vectors we were talking about?
The ones specifically trained for different tasks?
Yeah, definitely.
Well, get this. The researchers found that those expert vectors could potentially be transferred between different LLMs. Wait a minute, so they could take like a math expert trained on one LLM and just plug it into a totally different one, like swapping out parts of their AI brains.
That's pretty much it, like discovering a universal language for AI skills.
I know.
It's pretty crazy, right?
Super cool. I mean, if that really works, it could completely change how we develop these models. Imagine being able to share expertise across like a whole ecosystem of LLMs. It'd be like a giant library of AI skills.
Exactly. The potential is enormous. But before we get too carried away, let's take a closer look at how Transformer 2 actually performs. Before we got sidetracked, I think you were going to explain those confusion matrices.
Oh yeah, right. Confusion matrices. They sound kind of intimidating, but they're actually just a way to visualize how well a model is doing at classifying tasks. Think of it like a scorecard for that task detective we were talking about. The better the model is at matching prompts to the right domain, the higher the numbers along the diagonal of the matrix.
Right, exactly. And when you look at the confusion matrices for Transformer 2, both the prompt engineering and the classification expert approaches show high classification accuracy. But there's a bit of a twist here.
Oh, I knew there had to be a catch. Spill the tea.
Well, even though the classification expert, remember, that's the separate LLM trained specifically for task identification, usually does better than simple prompt engineering, it doesn't always lead to the best overall performance.
Now, wait a minute. I thought getting the right expert was the key to self-adaptation. If the classification expert is better at identifying the task, shouldn't it always get better results?
Well, it's not quite that straightforward. Remember those weighting coefficients we talked about earlier, the alphas, that determine how much each expert vector contributes in the few-shot adaptation strategy? It turns out those alphas reveal something really interesting. The model doesn't always just pick the expert that matches the task most closely. Sometimes it actually blends different experts in ways that, frankly, seem kind of counterintuitive.
So it's more about finding the right combination of expertise rather than just picking the perfect match, like, I don't know, a chef blending different flavors to create something totally new.
That's a great analogy. For example, in some experiments with a math data set, you might think the model would just rely heavily on the expert trained on, another math data set. But surprisingly, they found that the model often gave more weight to the expert trained on a data set focused on logical reasoning.
Really? That's so interesting. I mean, why would a model prioritize a reasoning expert over a math expert for a math problem?
Well, it seems to suggest that the model is learning to recognize these subtle connections between different types of knowledge. Like, even within a domain like math, there are nuances and layers of complexity that might benefit from insights from seemingly unrelated areas.
Huh. So the model is thinking outside the box and finding connections that we might have missed completely.
Exactly. And that has some pretty big implications, especially when we think about the potential for lifelong learning in AI.
It is pretty mind-blowing when you think about it that way. I mean, imagine AI systems that can constantly adapt and learn new things just like humans do.
Yeah, and seamlessly switch between all sorts of different tasks, like scheduling your appointments one minute, helping you write code the next, and then maybe even teaching you something new after that.
Wow, that would be incredible. We're talking about a whole team of specialized experts all rolled into one super adaptable AI system. That's the dream.
Yeah, it's definitely a big step in that direction, but like with any groundbreaking technology, there are some limitations and challenges to think about too.
Of course, no technology is perfect.
Yeah.
What kind of limitations are we talking about here?
So, yeah, where were we? Oh, right, limitations and challenges.
Yeah, I'm curious to hear more about that. What are some of the big ones we need to be thinking about as these systems evolve?
Well, one of the most important things is making sure that these self-adaptive AI systems stay aligned with human values and goals. As they become more autonomous and start making decisions without us directly supervising them all the time, we need to be super careful about any biases that we might accidentally build into them.
That's a really good point. It's not enough to just create AI that's intelligent,
Yep.
right? We also need to make sure that it's ethical and responsible. So how do we go about doing that? How do we make sure that AI is actually aligned with human values?
Well, I think transparency and explainability are absolutely key. If we're going to trust these systems to make decisions that affect our lives, we need to be able to understand how they're reaching those decisions.
But it's not enough for an AI to just give us an answer, right?
Yeah.
We need to be able to kind of peek inside its brain and see the logic behind it.
Exactly. It's like the difference between having a black box that just spits out results versus having a system that can actually walk you through its thought process. And that's where explainable AI comes in. It's a really important area of research, especially as self-adaptive systems become more common.
Yeah, absolutely. We need tools and techniques that allow us to understand how these systems are learning, adapting, and ultimately making those decisions.
Right. And this whole conversation has been so fascinating. We've covered a ton of ground today, from the nitty-gritty details of SVF and Transformer2 to these bigger questions about the future of AI and its impact on society.
I know it's been a wild ride. So before we wrap up, are there any key takeaways you want our listeners to walk away with today?
Well, I think the main thing is just how much progress is being made in AI right now. The idea of creating truly self-adaptive AI systems used to be science fiction, but now it's becoming a reality.
Yeah, for sure. It's a really exciting time to be following all of this. Anything else you'd like to highlight?
Oh, also, I think it's really important for everyone to stay engaged and think critically about all of this. It's easy to get caught up in the hype, but we need to keep asking those tough questions about the potential consequences of this technology.
I totally agree. We can't just be passive bystanders as AI becomes more powerful. We need to be informed, engaged, and ready to help shape the future of AI in a way that benefits everyone.
Couldn't have said it better myself. We need to make sure that AI is a force for good in the world. And, more than anything, I hope our listeners are walking away from this with a sense of wonder and possibility. We are just scratching the surface of what AI can do, and self-adaptive systems are a glimpse of what the future might hold.
Well said. And speaking of the future, I have one last question for you. If LLMs can already adapt to new tasks like this, what's next? Could we eventually see AI that's capable of continuous learning, self-organization, maybe even some form of AI evolution?
Wow, that's a big question. It's definitely something to think about. The possibilities are pretty incredible, but they can also be a little intimidating, to be honest. As we keep pushing the boundaries of AI, we need to make sure we're doing it thoughtfully and ethically, and that we're really paying attention to the potential consequences.
Absolutely. The future of AI is full of promise and challenges, and we'll be here on the deep dive to explore all of it. Thanks for listening, everyone, and until next time, keep those minds curious.